Welcome, y'all. Today I am talking about security and securing containers specifically for Java developers, and I will give you 5 tips. I can give you a lot more, but I will just zoom into 5 things that I feel and we feel are very, very important to you. But before I do that, we need to talk about what this word is. What is a container? Like, if you think about a container, you can think of different things. Like we like to replicate things from the real world as a concept into software development. But is that okay? I mean, normally a container is something that is a receptacle to hold goods in and to store freight in or objects or something like that. So you can think of a container as this, like the soda can or the beer can, to hold your beer or hold your soda to make sure that the flavor are all in and they are preserved, because that's what this container does. Same holds for this one. This one is an airtight container, and I store my food in that to have my leftovers so I can use it as breakfast or lunch the next day. But again, preservation of the stuff that you put in. But most of the people think of containers on this container, right? The container that you put on a ship, hopefully not on that big ship that was in the Suez Channel and was stuck, but hopefully you got your stuff. Anyway, this container is to transport goods. And all these containers have something in common. If you pick the right one, and that is one of the things, the right container, then it protects the containment from influences from the outside world. And that is good, because we want our soda to be good or our beer to be tasteful. But putting your beer in an airtight container might not make sense. Putting your beer in a shipping container doesn't last. So picking the right container is important. And all these containers are a layer of abstraction that help you support or help you protect and preserve the object inside or whatever is inside to the outside world. So let's mirror that thought into Java or software development, but specifically Java development. So I have my Java application in a container, which looks nice. The only thing is, where normally a container is there in the real world to protect from influences from the outside, in the Java world, that's not, in the software development world, that's not simply the case. It is, again, a layer of abstraction, absolutely, but it's not preserving, because we need to have contact both ways. We need to have contact from the Java program with the outside world. So just preserving stuff, that's not the case, because, well, user interaction is important and database interaction is important. And also we need to get stuff in from that same database or from maybe other containers. The point what I want to say is that although we like these concepts, it is not the same. Just putting your Java container, a Java application in a container doesn't make it safe, doesn't preserve it from the outside world, because there is two-way communication in this case. So we have to be a little bit smarter, basically. First, a few things about me. My name is Brian. I'm a developer advocate and engineer for Snyk, which is a security company, and we create tooling for developers. So security would be kind of easy or easier or better maintainable. I'm a Java champion. We already talked about that. Recently became one. Very proud of it. I lead a few Java user groups like the worldwide Virtual JUG, and I'm one of the co-leads of the NL JUG, which is the Netherlands Java user group. I'm based in the Netherlands, so you probably hear my English is not flawless, but a little Dutch. Anyway, if you hear some noise on the background, there are construction workers over there, so hopefully they will not mess with us today too much. But talking about containers, I will talk about Docker. Docker specifically because that is the default, basically. If we run a container, we can do a lot of things, but let's talk Docker, because there are many Docker downloads. People download Docker containers like constantly. And these numbers are big, but it's not even the point if this is exact or not. The amount of Docker containers is growing tremendously. So I will zoom in on Java applications and Docker containers and basically make sure that you do not fail your security for that. So the first tip I want to give you is, obviously, choose the right Docker base image for your Java application. Think about it. What do you normally do when you create a Docker file? You do something, the first line is something like this. From, in this case, I chose Ubuntu. Or you can say from another image. Because what you do is you pick an image from Docker Hub or any repository that is connected to your Docker files. And you pull that image and you put your stuff on top of that. So you're layering it. And the image that you base it upon, so the base image, is your foundation. But we did a little research in end of 2019. I did a little research on Docker containers, and we pulled the 10 most commonly used free Docker images from Docker Hub and tested them for vulnerabilities. And this was the result. And again, these numbers today might be a little bit different, but just to make a point that all these images come naturally with vulnerabilities. The node image, the HTTPD image, the Postgres image, all of them. These were the top 10. And the point of these things is it's not so much the node image that in this case was the problem. No, it was that node image also is based upon another base image. And because I just did node, I automatically got the latest version. And the latest version was a big version based on, I think it was at that point, some Debian distribution, Debian Jessie maybe even. And all these 500 something problems, almost all of them could be traced back to that layer. So to the whole operating system layer. So let's dive into operating systems, because picking an image based on what operating systems makes a huge amount of difference. And that's for a reason, because if you pull in a complete operating system like full-blown Debian, first of all, you have to think, do I actually need that? Do I need all these binaries that come with that operating system? Do I need that if I just bring like pulling up a small Java REST service or something like that? Do I actually need all this stuff? And probably not. But because we read this on blog posts and Stack Overflow, we might just do it, and it works. But picking your base image, even from Debian to Debian Slim, already reduces the amount of vulnerabilities that come in the operating system layer. And it's, again, we are responsible for the application and the container we deliver in most cases. If we, for instance, run in a private or public cloud or cloud-ish environment. It's not that, hey, I'm only responsible for my application. No, it's also the container, the abstraction layer around that. And we should think about this, because you might be able to base your image upon Fedora or Alpine, which reduces the amount of vulnerabilities tremendously. Let's go into one of the more known images for Java, which in this case was from Adopt OpenJDK. And I use the Adopt OpenJDK 11 image. And if I do the default, then I will get the Ubuntu one. So that's the one with 25 vulnerabilities. And that's already okay, because, hey, if I use the Debian one, I have 75. And of course, not all these vulnerabilities are directly executable, but it's, well, you have them. And that means that if somebody finds a chain that they can connect a certain entrance in your application or in your container towards that vulnerability that is there in the operating system layer, it might be harmful. And if you're not having that, it cannot harm you, basically. So you can choose the latest one, but you can also choose the Alpine one if that is suitable enough for you. At least you should know what you put in and not blindly put it in because, hey, it works, ship it. We need to take care of that, just like we need to take care of maintainability and scalability. So I just, what I did, well, I scanned just before this presentation, I scanned something here, maybe you can see it. Yeah, let me enlarge this. I scanned the Adopt OpenJDK image for now, and at this point, the Ubuntu one has 22 issues. And all these issues are, again, connected to the operating system layer. So taking care of that is already a very, very important step, because what you don't have can basically not harm you. Cool. So next one, only use what you need. And that's already like, I already said that in the base image, but it's more than that. For instance, look at this image. This is interesting, right? This is something you can pull from Stack Overflow, like, hey, how can I build a Spring Boot image by my Spring Boot application with Maven? Let's put it in a container. And you probably stumble upon something like this. And I have a real live example over here, which, well, is this. You see, Maven 3 OpenJDK 11. I just copy. I just make sure that I create a project. I copy the stuff. I set a work there, and I use Maven to build and spin everything up. And that is cool, I think. But like doing this, and hopefully I'm in the right directory. This takes too long. Let me just enlarge it first, because that is always what we need. So it is on my demo. No, it's on, yes. And this is just, I'm reusing a code workshop I used a few years ago. But if I build this image I have over here, I do something like docker build -t, and let's give it a tag, Java code workshop, which makes sense, #1 dot. Now, so now it will build the image. And what you see is that this build image contains a lot of stuff. We will go back into this and I will show you that it's actually quite large. Because what we do over here, we use every single thing. And when I tested it previously, it was up to 800 megabytes big, and it probably will now be even bigger. And then we have to think of that. Do I actually need all of this in the container that I put into production? Probably not. I mean, there is a difference between what I need for build time and what I need for runtime or execution time, basically. So in Docker, we have something that can help us to make sure that our build stage, if I want to do that in Docker container, can be separated from our production stage. And we call this multi-stage builds. And let's just do a multi-stage build right away. It's still building, that doesn't matter, but we can already adapt that to Docker image. So this one is a very large image, and it contains Maven, it contains the complete JDK, and it contains my code. And the only thing I actually need is a Java runtime environment and the artifact I built, right? So if I still want to build this in an image, I can do something like this. If I do as build, I give it a name. And yes, I prepared this, of course, so I do not mistype a lot of things. So instead of just putting this container right to production and give it a command, I'm now putting up a second image. I create a second image, which is my production image. And this image is based on Alpine, on the OpenJDK 11 Alpine Java runtime environment. I don't need the machine that builds the car, and I only need the car itself. So what I do, I copy the jar file that I actually need. I set the work directory, and I basically call it Java -jar because this is a Spring Boot application that is already self-executable. And that is interesting because this one, I just built the one. Now let me just see, Docker image ls. The one I just created, that is the JCW1, is again over 800 megabytes big. If I build the same thing now, and it will probably take some time, and we can go back to that, but it will be a lot smaller. So just not to waste any time, I might be coming back to this as well, just to show you proof that the same thing works. But the point is, by separating the two, not just using an image that contains Maven, contains my Java runtime environment, contains my code, I just take what it needs. And the interesting part over here is I can do a lot of stuff with that, but it's also a lot smarter. In this case, when I tested it, it was just shy of 200 megabytes, and the other one was over 800, almost 900 megabytes. So that helps me with shipping the container, with building it up, with probably also with execution. And more importantly, what stays in that top part of your application or of your container, so the Maven 3 image I'm using to build the stuff, I can use all sorts of stuff I need for build time. For simply, say I need a username and password. I don't want that username or password somewhere in the cache layers of my product image, my image that I push to production. No, I can now separate that. So I need it when on build time. And actually what's over there and when I put in there for extra stuff that I need when I build my artifact, I'm not copying it over to the image at the end. So it's not there. So it's also not there in the caching, somewhere in the caching. So with a history check on Docker, I cannot see what for instance, the username and passwords are. So if you need to build these kind of things, multi-layered builds like this are good also to protect your secrets. Let me get back to see if that thing already built, and it already built. Just to show you quickly that the number 2 over here is just a little bit bigger, but it's 197 instead of 895. You see? And it does the same thing. It holds the same binary, and I'm only interested in the code that is executed and that it runs on Java 11. Cool. And I saved a lot of space, and I saved a lot of, well, headaches, I guess. Next one, the least privilege principle. And least privilege principle is an interesting one. Because what we basically want with the least privilege principle ever, it's not only for Docker, it's not only for Java, it's always. You want to make sure that the people or the person or the user, if I make it abstract, can only do what it needs to do. Nothing more, nothing less. Just do what it needs to be, what needs to be done. So making sure that it has enough privileges to see what and execute what it needs to do, but not more. Less would be problematic as well, because then it doesn't execute, or then you have a, well, functional problem. But if you have more, then you probably might not see it. But if somebody breaks in and a user has more privileges, you don't want that. For instance, if I'm in the hospital, I want my doctor and maybe the nurse that serves me to make sure that they know what I have and what my medical history is, not the whole hospital. Like the other doctors on other departments, they don't need to know that. It's private. It's to me. They don't need to see it because they can lose it. And if it comes back to my insurance company, they might charge me more, because then they see what kind of, well, let's not get into that I'm an alcoholic. No, I'm not an alcoholic. But you get my point, right? We do not want the information to the wrong hands, and we can restrict that by privileges. And like everything else, it is part of a chain. Attacks are always part of a chain. And make sure you break that chain of attacks in multiple layers, because if something goes wrong accidentally, you do not want to escalate that and make it a domino effect. How do you do that in Docker? Well, I have an example over here. Again, that image that I showed you with the multi-stage build. Just showed you previously. And let's go into that production part, the production image that I put into production. That is interesting, but you know what Docker does if I'm doing it? It runs the jar file as the root user. And if you read Docker blogs, you probably stumbled upon these things quite sometimes, like don't run your container as root, and don't run your container as PID 0 or your application PID 0, but that's something different. But don't run it as root, because we simply don't need to. And restricting that is always a good case. So side effects will not turn up. And how do we do that? Simply doing this like this. But yeah, let me just for you highlight what's important. These 3 yellow lines are important. Just focus on the 3 yellow lines. What I do in the first place, and remember, this is an Alpine image. So if you base it on an Ubuntu image, it might be, the commands might be a little bit different, but this is specifically based on Alpine. So I add a group, which is a system group, and I create a system user with out shell access, and make sure that is there. After copying, or after creating the project directory and copying the jar, I could do that before that as well. But after creating the work directory, I set ownership to that project directory for that new user I created. So that user has ownership of that directory and nothing more. It cannot do anything more at that point. Then the third line is also important. The third line is so important that at that point, I call that user. So every command after that is called by that specific user. If you forget that third line, it doesn't make any sense anymore, and you just run it as root. You just created a root user, but you're not using it. And remember, a lot of these images that are out there in the open that you can use from Docker up might have a user as well, might already have a less privileged user than the root. If you want to use that, you still need to call user and that specific username to make sure that it works. For instance, I know that the node images have the node user by default there. Not well documented though, but you can use it, but you still need to call it user node in this case. In this case, I'm calling user Brian Vermeer, which is the user I just created. And now my jar will run as that specific user and not as root anymore, which restricts the privileges, and that's good. Next up, scan your Docker images and Java applications during development. And it's both. It's not your Docker image or your Java application. We're responsible for the whole shebang. So we asked a lot of people a bunch of time ago, like in our yearly State of Open Source Security, we asked them, when do you scan your Docker images for operating system vulnerabilities? And a lot of people, unfortunately, don't, which is interesting because, hey, it's another layer of abstraction that you are responsible for. So what you can do, you can use tooling like the tooling that Snyk provides to scan a container. And that container can be scanned like this. And well, I just already did that before. Like I can scan the the image, I can pull an image, and I can scan a specific image that I just pulled. And you get something like this, like what are the vulnerabilities and how many vulnerabilities are there, and how severe are these vulnerabilities. So not to say you have to restrict all of them, but you can make, by knowing this, you can make a well-known and educated choice if this is the good image for you. And it's not only your base image, because base image is one thing, but you put in binaries as well. And we put these binaries that you put in there, we can scan them. Most of them, we can scan them as well. And more importantly, we need to do this over and over again, because at the point in time now, it might be super perfect, but maybe tomorrow there's something happening, or maybe the day after, but you already built your image. You already built that image and maybe set it already into production. So what you can do is two things. You can scan your container, like with Snyk container test, and then the image you just have, and for instance, put it up to the path of connect the Docker file to it. So if you can do that, in some cases we might be able to give you remediation advice on, for instance, the base image. Like, hey, maybe use another base image so you will have less vulnerabilities. But besides that, you can also do a Snyk container monitor. And what does that do? Like, hey, when I go to production, I take that monitor and I take I basically take a snapshot of this in time, and I save that snapshot and scan that on a daily basis. If I do that, I know that if something comes in tomorrow, because basically the software that I put in and the binaries that I put in are static. If something is found, we can report it right back to you. And you're like, okay, now I need to do something, or it's not harmful for me. But you can make, again, an educated decision. And well, it's quite easy. Let me just quickly show you. I didn't prepare this, but that's interesting always. Say I can do a Snyk test on, say, a Snyk container test on the thing I created, JCW2, and I can just, my file is the Docker file, which doesn't maintain anything, because for the Alpine one, I know there's no remediation thing, but anyway, I can do something like this, and it scans my current image that I created on a daily basis. If I switch out that test for the container statement, it will load it up to the Snyk UI, and it will make sure that it will be scanned regularly. And you can see that there's no recommendation for base image available for Alpine at this point, because there is no better base image at this point, because that base image already contains 0 vulnerabilities. But you see there's no vulnerability in this case, because I based it, well, my program doesn't have any vulnerabilities, at least not in the things that we can scan, and my container doesn't have any. So I can safely push it to production. All right, enough about this tool. Getting back to the slides. But again, that was your image, your Docker image, and that is part of what you need to do. What you need to do as well is think about your application as well, because if this is your application, lots of that application is not the code you wrote, probably. Probably the code you wrote was something like this. Fair, right? Because this is the business logic, and I pulled in my example, for instance, I pulled in Spring Boot, which pulls in a lot of other dependencies, and all these dependencies are layered. So that means that Spring Boot starter contains another thing, contains another thing, contains another thing, and another library below. So a lot of things are not direct dependency, but indirect dependencies. And if I look at the code that I actually pull in, it's a lot more than the code that I wrote. However, for the code that I wrote, I might have things like code reviews in place, or pair programming, that we make sure that it's not happening, that there's no foul in it. But how do you think about the frameworks and the libraries you use? Probably you just pulled it in and you didn't look at it. Or did you? If you did, great job, 100 points. Please continue hold that thought. Because most of the problems are not also always in the top level dependencies. For instance, if you pull in a Spring Boot starter, it's just an empty shell. It's just an empty jar with a POM file with a lot of more dependencies. So it's not, most of the time, it's not in the top level dependencies, but somewhere down below the chain. So we need to make sure that we know what we pull in, because we're responsible for the whole application and the container. So if I just look at that little bit of my code, that might not be enough. And then people will come back to me like, what can possibly go wrong in my application? Because I'm great. Well, let me show you. I have an application that I used some time ago, and it is a, not this one, because this one has some vulnerabilities, but it's more on the code I wrote, because I wrote, well, specifically harmful code. But let's get up to this application. Yes, my Spring Goof application. And what Spring Goof application is, it's a small application built. Oh, I need to enlarge the screen. That is built on top of Spring Boot. And as you can see, if I start it up, it gives me a grocery list. Beans for 50 cents, milk for $1.09. It's probably before the pandemic, because now everybody needs to get that stuff inwards. Well, however, nowadays things are much, much more expensive, depending on where you live, of course. Anyway, it's a grocery list. Nothing really important. Also, what's not important, but I just want to show you, is the domain entity. And the domain entity is a name, a cost, and an ID. I generate the ID, and the rest are getters and setters. Not using any kind of magic as Lombok or whatever. Just a plain old Pojo, completely with the in the bean style. So let's go to the repository, because this is getting interesting. This is the repository, and I'm using Spring Data and Spring Data REST. And for Spring Data, I just need to extend my CRUD repository. And the CRUD repository, okay, is cool. What I need to do, just by convention, if I just put in this interface a single name like find by name, and I give it a name parameter, it will automatically create the SQL for me that connects to my application, to my database. I don't need to write the SQL myself. I can write the SQL query myself like I do here, but for a lot of these things I don't, which is cool for prototyping, POCs, MVPs, however you might call them. So I can continue. And what I continue is to do, I use Spring Data REST. And with Spring Data REST, I add this annotation, repository REST resource. So my CRUD repository will automatically be transformed into a CRUD REST endpoint. So I can do the find by name by calling a REST endpoint, which is cool. And if I can do that and it all works, I just can go on to ship this already, and my front-end guys can do the app or the application or the website or whatever they might be doing. So let's run this, and hopefully it runs, because you need to pray to the demo gods probably several times a day. And I didn't. I did only once. And it works. That is amazing. So let's just spin up a browser. Let me just get a new one over here. Let me just show it here. So I will go to localhost 8080, which is, and it will redirect me to my Hell browser. My Hell browser is just to show you things like, hey, I can just call this endpoint /item/1, which is there initially to give me the first item in my grocery list, beans for 50 cents. And of course I can do 2, 3, 4, and 5, which gives me the things that I need. What it can do as well is I can, that CRUD endpoint, find by name, and name is beer. I now can access it as a REST service. And cool, it will give me my beer. So I wrote tests around it, and it works. And even if I do authentication authorization, which I didn't do in this application, it still works, and I can perfectly fine. But there is a problem with this application. And the problem is, let me get to my thing over here. And I will show you the issue from my terminal, of course, because hey, no great hacker would do this in the browser, because that doesn't work, or it's not cool. So let's go to demo Snyk. I think it's Spring Goof. Yes. Let me go to the exploits. And what am I showing you? I'm showing you that I will do a curl patch request in this case. And if that patch request, I will serve it a very weird content, a very weird body. And the body would be something like this. It's a JSON body. Oh, let me just enlarge it even more. Yes, that looks better. All right. And as you can see, this is the body I will put into my curl request in a second. And that body is just, actually, the structure is JSON, right? It's a list of an object. But the key value pairs are a bit weird, because what I can do if I do this with a curl patch request, for some reason, I am allowed to execute SPEL, the Spring Expression Language. And with an expression language like this, like the from Spring, but also the old-fashioned OGNL from Struts 2, for instance, I'm allowed to, with this expression language, I'm allowed to interfere with code, with stuff that is there. Like I can get things, I can set things, I can maybe even create new objects. And what I'm doing here, I'm just getting the runtime and execute something. And I feed it an arbitrary command. So if I can do this by just pulling a weird request, executing SPL, executing expression language, and I can just create a new runtime with a new command, I have a lot of power. So let's go and look at the SWD file, for instance. It is interesting. So let me copy paste this so I can explain it to you what's happening. And this is just because the program runs. So I do a curl patch request. I have this JSON body over here, and instead of command, I now create a /etc with some spacing characters and /passwd. So I go into my passwd file on my system. But I fire up this thing on the localhost item/1, which was the one for my first grocery thing, right? Anyway, if I do this and I execute it, I will have the content of my passwd file. And if I can do this, because I just run it locally, and unfortunately I run it as root, so I have a lot of power. So I basically can call every single argument or every single command that is available to me, like creating directories, removing directories, moving everything, creating a script and installing, well, creating a script, not just the file, but also the contents that downloads maybe something else that I can, well, you see how my chain works now? Because I can do this, I might be able to do more. And if I, for instance, can connect that to things that are there on the system already, I can just look around and expand my reach in this hack, not only in the system, but also towards the Docker container, and maybe even further if that is possible. So it's not just securing one thing and then you're done. If there is, for instance, something like this, you might be vulnerable. And what can you do about this? Well, that's quite easy. What I can do is, I'm using my Snyk tool again, and I'm using it from the command line, but I can also use it in IntelliJ, for instance, and it will analyze, in this case, my dependencies and see what kind of things are wrong with that. And I'm using outdated dependencies that are already fixed. The problems are already gone. However, I need to make sure that I update enough. Of course, some things cannot be fixed, like an H2 database, which I use for demo purposes. But for some things, we can, because of the layout, because I zoomed it in. Now, for instance, I say over here, I'm using a starter 155 build snapshot. Never use a build snapshot. But if I change that to JPA 2.12 release, that it's fixed. And that information is good for you as a developer, because now you have actionable things. And I'm not saying you have to use this tool, but use tools that fits your process, right? Not just saying you're doing things wrong. Just want a disclaimer, everything I use here, you can use for free. So there's no paid things. I don't like paid things. However, so you should be scanning both your container and your application. And if you don't know what's in your application, it can go wrong as well. And combine that with all the harmful things in your container, it can be disastrous. And that's not what you want. So I showed you what could go wrong. Next and last thing, build to rebuild. And that means that if you have an application in a Docker container, well, you probably have more than that, because we work on the cloud nowadays. So we spin up another pod and another pod and another pod using Kubernetes or whatever is cool, whatever the cool kids do nowadays. But for instance, say we have, for this discussion, we have three the same applications, because it's good. And we find out, because we have superb logging, we find out that in one of these things, somebody's active. Like, hey, we see weird things that might be that is breached. The first thing that you want to be able to do is like immediately blow it up. Immediately. Because, hey, now the hacker is not active anymore and needs to start over again. It might be easy to start over again, but he needs to start over again, or she, of course. And we want to be able to spin up a new one right away, and that it comes to that cluster back again. Preferably a new one that has the fix, of course, but you need to think about your strategy and about your architecture in that way already. So if you do that, you have to make sure that if you create a container, that it doesn't contain all the things that do not belong in a container. For instance, don't make sure that it's not containing, like that you're not writing the logs in your container itself, but on a centralized point. So you can actually see what's going on, and they are preserved when you just instantly bump that red button and blow that specific pod, that specific container up. Same holds with the database. In this application I showed you, I use the H2 database, which is perfectly fine for demos, but not so much in real world because it's in the container. Even if you use a Postgres thing, don't use it in the container. Make sure that it's out. Also with cache, make sure that you are aware that if you blow things up, that the cache is gone and it might impact usability. So you should be the cache or outside or as part of your container that it automatically regenerates. For instance, use a memory data grid like Hazelcast or something similar that automatically fixes the stuff. So think about this from the point that every container needs to be disposable at any given moment. It doesn't contain anything but the code and the connections to the worst thing. But if something happens, blow it up, put a new one in. Makes it easier to deploy just for you as a human being or your operations team. But also, if something goes wrong, you can easily fix it more. And if you need to make sure that there are backups and you know what, that's the whole old story. That hurts. So make sure all these things are outside of the container, that the container only has what it needs. And did you know that 44% of the Docker image vulnerabilities can be fixed by just putting in a newer base image? So that means that, oh yeah, we ask people like, hey, how do you find out about new vulnerabilities in the deployed containers? A lot of people don't, which is interesting. But think about that. If you just switch out the base image to a newer version or some other version based on another operating system or that doesn't harm your application because, well, that's what we're looking at, but it can already fix a bunch of things that are actually vulnerable. And more importantly, 20% of the Docker image vulnerabilities can be fixed by just rebuilding the same image. Because we do a lot of this. We do a lot of, hey, get me from Ubuntu. And I now already said latest. But it can, if I don't do it, automatically passes the latest. But the latest now is not the latest tomorrow or the week after. So if I do that and combine it with binaries like I do here, I install Python with apt-get. That might not be, well, it might be an interesting thing. But if I do that today, it has different binary than tomorrow. So by rebuilding your images, your containers on a regular base, even if your application is not so much changed or not changed at all, is wise to do. Because of this, just rebuilding this gives you a better image every single time because people find these issues, fix them, and bring out a new version. If you say, hey, I want a deterministic build and I use a SHA hash for my image, then you need to update that image as well, but not just rebuilding it, but make sure that you put in the newer one. You get me? These are not deterministic builds, and if you do deterministic builds, you still need to rebuild this thing because newer images will just be released on a daily basis or on a weekly basis or even like regularly. And by updating that wrapper, updating that container, it can help you already fix a bunch of stuff that you don't need to take care of. If you do rebuild, however, make sure that you use the -- no cache option in Docker. So Docker build -- no cache to ensure that you do not have a cache hit for some reason. Because, hey, do we trust machines? Not at all. Why? Because we program them ourselves. Anyway, doing this, make sure that cache hits will be ignored. So to sum up whatever we need to do, and these are just 5 things. We can do a bunch of more things, but these are 5 essential things. Choose the right build image when you create a Docker file for your application. Make sure that you only use what you need to be using. Like many cases, you don't need the full JDK with all of it. You don't need the machine to build the car, but only the car, right? And to build, in this case, to run the car, to run your Java application, you only need a runtime environment in many cases. So make them as slim as possible, because what you don't have cannot harm you. Don't ever, 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 ever run as root. Make a specific user for it if it's not already there. And run that user. Don't forget it to use that user as well. Scan your application, both your applications and your images while developing, but also when you're in production. Make sure that you have that monitor in place that takes a snapshot and goes over it on a daily basis. So you get actively pinged when a new thing is found, because, hey, it's done, it's to production, it's not my fault anymore, and continue to implement new features is interesting. But the thing that is in production, that is the point where it's harmful to the outside world. And make sure that you orchestrate and you architect both your containers and your application so it's built to be disposed and rebuilt again. If you want to know more, we created a 10 best practice sheets. I did that for Snyk, and it's here on the it's on our blog, and then you can see that we actually have advised you, for instance, on the first time to make deterministics build, so you can make sure that if something goes wrong, you can actually check it. Make sure that you're not running as PID 0, use Docker ignore, for instance. Now, and more of these stuff if you're interested in that. But these are the 5, I think, most important points I just showed you. That's about it. And I'm at the 40-minute mark right away. So if you have any questions, of course, ask them now. But if you do not have a question now, and like tonight when you're like drinking your well-deserved beer, you think like, that Brian dude says something and I have a question, ping me on Twitter anytime. I will try to answer that question. And if I don't know, maybe someone else in my network or in our team knows, and we can redirect it to you. So don't feel free to ping me if you need to. Everything I showed you, of course, is free, because or else I would, it doesn't make sense. So you can use it, but more importantly, think about it. Think about that you need to take care of this. Amazing. Thank you.
Amazing indeed, Brian. Thanks a lot. Really insightful, and cool tips to have in mind.
All right.
Once you look at it this way, it's not that scary once you know what you need to do.
If these are just simple steps, and actually a lot of people write Docker containers and just like the naive way I did it in the beginning and just put it to production. But if you say like 10 years ago when you build upon that old IBM WebSphere, did you also do it that way? No, I made sure that was a user that is specifically for that web server, and then I'll take care of that. But now then this Docker images, some people think like, I can forget about it, which is say basically the same knowledge, but we just have to do it in a different way.
Yeah, and it's because I don't know, it's the whole abstraction thing, and I'm using Docker because I don't need to take care of these things, but it's not completely. You still need to manage. Yeah,
but in the end, even though Docker is a very, very very cool technology, there are layers. There is still an operating system layer. There is still an application layer, and we need to take care of this as well. Only it's now compartmentalized in a container, so it's a smaller thing, and I can run more of these. But we used to do the same thing with virtual machines. So the best practice doesn't that much change. However, you need to know like what's going on. Like if you don't know that Docker runs every application by default as root, that's something to like, you have to know what you're using. You need to be aware of what you're using. And that is the whole point here.
Indeed. And since you mentioned the past, I want to ask you, what's let's say the most horrible thing that happened to you from the security point of view that you can tell about?
Well, I can tell about one problem we had, and that was like in the past life, like when I was working as a Java consultant for a major company in the Netherlands, and we found out that we were in our application that was multi microservices application, there was a data leak. What we did was, instead of looking at what we put out in the output, like what the actual output needs to be, we outputted the whole POJOs, which was perfectly fine, and it worked for the application, but it also contained an ID. And if you get that ID from the one REST call, the raw REST call, and you put that as an input into another REST call. You will get information, and if you connect the information all together, like from 2 or 3 REST calls, you would have personal identifiable information. So you had a GDPR issue. So luckily somebody found out and reported it to us, and we found and fixed this in, I think, within 10 minutes. We found where the problem was. We made a fix. We deployed it to production. So finding it was the hard way. Fixing it was like 2 minutes to production.
Yeah, some things are like that in the...
What the hardest part was the aftermath. Like managers coming up to you, like who was involved? Why did this happen? How long was this in? Are their customers compromised? And we're like, I don't know. It might be. We do not have logging on that. So these kind of things come up, and it took us months on reports and doing things because management was all on top of us, and that was the hard part. Not the execution of the software or fixing it, but the dealing with management. That was the hardest part because they want to cover the things up or make sure that they are in a good way. Like if somebody comes up and sues you, that they know what they're doing. They need to go out into the public that we have a data leak. There might be a problem, which we were not sure if there actually was. So the aftermath was the most devastating part, and that covered that ruined our lives the 3 months after the incident, basically.
Yeah, so like I said, it's good to tackle these problems as you are developing. And
as you're developing, like why not do it on the beginning? Like when I create a Docker image or when I create an application, make sure that if you're like building security in from the beginning, just like you do with scalability, if you don't think about it, but you think about afterwards, like, oh, it's not only needs to work for 2 users, but for 2 million users, you might have did some things differently in the beginning. Same holds for security. Like start from as a developer on your local machine already. Think about it. And if that starts to resonate, it's not that hard to cover the 80%. Of course, there's the 10% that is super sophisticated, but if you already cut the obvious things, you're already on a good way, my friend.
Yeah, so that's stuck into my head that you need to monitor this on a you even mentioned daily basis.
And then pick the tooling that fits your process, like pinging on a daily basis. I don't have to take care of it unless it pings me. So I do not have to, if I need to set a reminder in my calendar, look every day in the logs. Yeah, I don't do that. I forgot it maybe. And now I don't have to think about it. I automate stuff, and that already helps.
Yeah, great stuff. Thanks again, Brian. Really worth knowing or being reminded about these tips. And yeah, hope to see you again next time.